Hello everybody, and welcome back to the Poor Man's Chemist. In this video, I am going to try to make some small amounts of some weird ruthenium compounds that I was reading about this morning. They were so bizarre we couldn't even come up with the proper name for one of them. I'm still not 100% sure what you would actually call this. But I found it in this book, Ruthenium Chemistry. Of course, the reference is in the description, as well as a link to where you can download it for free if you want to follow along, although there isn't much to follow along to. This is coming from page number 73. The first one is a complex of, it says potassium ruthenate, cyanide. In their case they use sodium cyanide, but I'm going to use potassium cyanide because it's the only one that I've got. Although since it's potassium ruthenate, I don't guess that the potassium ion is going to be that big of a deal. And apparently this yellow compound will precipitate out so long as it's in the presence of cesium ions. So there's some cesium chloride here, it being the only cesium salt that I have. This is very much so quick and dirty kind of thing, especially because although the ruthenate came from about 1 gram of ruthenium, it clearly did not all react, so I'm not exactly sure how much ruthenate is going to be in the solution that we're going to use. But I mean, the one sentence that describes this compound in the textbook, oh my god, it says that this compound will precipitate out in the presence of cesium ions, so I really hope this is going to work. If it doesn't, you will never see this, so it won't matter. So let's give it a try. Alright, so what I've got here is a solution of potassium cyanide and cesium chloride. This reaction would probably be a lot easier to do if you're one of those very few, very lucky chemists on the face of planet Earth that actually has cesium cyanide. That would probably be very convenient. Alright, let's try adding a drop or two of this in and see what we get. Okay, maybe more than a few drops. Well, are we getting anything? Is it too dilute? That is entirely possible. Interesting. Is that? Okay, so here's what the solution looks like with it being in the evaporating dish. It's kind of a greenish yellow, but it is a definite yellow, and that is not the color of potassium ruthenate. So that's highly encouraging. So I'm going to just let this evaporate down here with the fan going, and we'll see what we get. Okay, people, so here it is. It's not quite dry, I don't think. I don't know, I can't tell. Yeah, it's kind of like goop. But it is definitely not ruthenate. It doesn't look like any ruthenate breakdown product that I've ever seen. It is slightly yellow, and probably most telling of all, it has not broken down into ruthenium metal, which if you've ever worked with potassium ruthenate, you will know it decomposes to ruthenium metal all over the goddamn place. Case in point, this beaker has had potassium ruthenate solution in it here for, I don't know, an hour or two. Probably not even that long. And it's already depositing ruthenium metal on the glass. If you heat it up, this will happen even faster. Hello, don't not focus like the old phone. Don't pull that shit. So, I mean, the fact that there is not the slightest hint of it breaking down here in any way, shape, or form, honestly, you know, I'm going to take a guess, and it's going to be wrong, and hopefully by, you know, the application of Cunningham's law, I will find out the right answer because somebody will be dying to correct me. I am going to call it pentacesium nanocyanodiruthenate. So yeah, if that's wrong, inorganic chemist, please feel free to mock and ridicule me just so long as you give me the correct name. But that's it. Whatever the hell it's called, we have created it from one sentence in an obscure textbook. That's pretty goddamn good, I think. Alright everyone, for the second experiment, I am going to try to make another compound that I read about in the same obscure textbook, which was well, basically they described adding ammonia or trimethylamine to create either ammonium ruthenate or trimethylammonium ruthenate. I don't have trimethylamine, but I do have diethylamine, and I have triethylamine. And I have concentrated ammonia. So I figured, what the hell, we'll give it a shot with all three. This was one of the rare ones, or at least one of these was, where I filmed it, or tried it before I filmed it. Another day of too much caffeine, pretty much like every day. And with triethylamine and potassium ruthenate, I got a black compound. I don't think it was ruthenium metal because it did not deposit on the glass, which ruthenium metal absolutely does, as we've seen. And it formed what looked like fairly, I mean, I don't know, it's my little cheap dissection scope had a very hard time resolving them. But, I mean, you could see where some of them were clearly crystalline. So, I mean, to me it looks like we're getting the compound we should. Now, unlike the previous compound, you know, and with so many fucking chemistry textbooks, the authors did not deign to tell us the color of this fucking thing. Why they do that, I do not know. If you're writing a goddamn chemistry textbook, will you please put the fucking color of chemicals in there, for God's sake? That is so fucking obnoxious when they don't do that. It's like, you know, what is the first way chemists are going to experience a compound? They're going to look at it. So could you tell them what it's supposed to fucking look like? Sorry, rant over. That just always gets on my damn nerves when they do that. It's like, you know, anywho. All right, so here we go. I know, I try to keep my videos positive, but, I mean, when you're not making stuff that's like, you know, borderline drug-related, you know, material, and you try to do weird, exotic, you know, compounds that nobody's ever heard of, it's hard when they don't even tell you what the hell color it's supposed to be. All right, here we go with ammonia, potassium ruthenate. Okay. Maybe they meant ammonia gas? That is possible. Ooh. Well, something is clearly happening here. All right. Oh, whoa, we don't want to do that. That's sediment from the bottom of this shit. Not all of the ruthenium metal reacted. Oh. Okay. Something happening here. Okay. Oh well. We'll move on. Yeah, no, this is what it was like for triethylamine. I immediately got this black precipitate. A little bit more here. Alright. It's almost, let's see if I can do this so you guys can see it. Closer, you can see it almost has kind of a greenish tinge to it. Zoom in here, make sure it's focused. There it is. See that? It's almost brownish, greenish yellow. That's interesting. Okay. Well, there's that one. Here's the ammonia one again. Still, I mean, it's changing colors, but nothing's precipitating out. You guys can get a good view. There you go. Add some more in there, since that's what I did last time. Yes, there it is. There we go. See the crystals in it now? Look at that. Well, if nothing else, it appears we may have gotten triethylammonium ruthenate. Maybe. But look at that. That is a definite precipitate. That's not ruthenium metal. If it is ruthenium metal behaving in the weirdest goddamn way I have ever seen, and I have played with a fair bit of ruthenium. That's a compound right there of some kind. Alright, time to check in on our other creation that I've been drying under vacuum for a little while now. There it is. It hasn't broken down to ruthenium metal, except maybe like a teeny bit right here, but when I was evaporating this stuff down, a bit of what, I don't even know what, fell from the tree into it, because of course it did. I managed to fish it out before it had done too much damage, but it was off to the side like that, so. But there you go. I mean, it is a very pale yellow compound. Let's see if that's better. I don't know, I hope you can see that better. But there that is, and here is our other one. The presumptive triethylammonium ruthenate, along with the compound with no name. Anyway, if you guys like this little exploration into very strange and unusual ruthenium chemistry, give this video a thumbs up. If you didn't like it, well, I don't know. I don't know what it takes to make you happy then. Subscribe, comment, share the video. Please, comment. Tell me how stupid I am for not being able to figure out the name for this compound. I don't care. Mock me to your heart's content. Just tell me what the fucking correct name for this thing is, and I will be happy. And until the next one, y'all, I will see you later.